Hi everyone, I am SS Kiran. I would like to discuss about short questions with answers in BJT and FET. In that chapter, I have to discuss, these are all topics and most probably I will cover all the topics also. Okay, these are all questions you may face at the time of interview. The following questions are like this. I have prepared around 1 to 35 questions. Just you can see. I have read some questions randomly. You can understand the strength of these questions. The first question is define transistor. Okay. The first question is define transistor. I have read randomly. Right. Fifth question, draw the symbol of NPN and PNP transistor. Right. Then 10th one, what is meant by base width modulation in transistor? 15th, explain working principle of phototransistor in brief. These are all short questions. These questions are very useful in end examinations also. Okay. And then like 20th, sketch the simple FET and explain. 30th, draw constructional diagram of N-channel enhancement MOSFET. Then 35th, what are the advantages and disadvantages in BJT and FET? These are all the questions. Okay. Then next we enter into a question with answer, detailed explanation. Okay. Right. Our first question is define transistor. If any question asks in end examination, first you have to make up like this. Okay. Just put a transistor and do some headings like this. Okay. Now we enter into the definition. Yes, obviously transistor is a 3-terminal semiconductor device. Very important. Transistor is a 3-terminal semiconductor device. Just you can observe there is a 3 terminals, namely emitter, base, the third one is collector. Okay, transistor is a 3-terminal semiconductor device which is having 3 terminals, emitter, base, collector. You can also observe constructional diagram or structural diagram. There is a N, P, N. Okay. 3-terminal semiconductor device which the operation depends on. Operation means the current conduction process has been done both majority charge carriers and minority charge carriers. Okay, which the operation depends on the interaction of both majority and minority charge carriers. It is used in amplifier and oscillator circuits and as a switch in digital circuits. Very important, it is used in amplifier and oscillator circuits. Okay, and the coming to final definition of the transistor. Transistor is a 3-terminal semiconductor device which is having 3 terminals, namely base, emitter, collector. Okay, the important one is which is amplifies weak signal into a strengthened signal. That is fine. This is some structural diagram. This is symbol of the transistor. This is our first question with answer. Okay. Just you write like this. You will get good marks in your end examination. Right. The second question. Just you can observe the second question is draw tree diagram of transistor types. Okay. You know very well there are 2 types of transistor. One is BJT and second one is FET. BJT nothing but bipolar junction transistor. FET means field effect transistor. There is only uni junction. That's why you can also unipolar junction transistor also, not UJT, right? BJT. Coming to BJT, BJT is classified into two types. One is NPN transistor, another one is PNP transistor. These two transistors, okay, coming to NPN, it operates or configurations in three modes. One is common base, common emitter, common collector. These three are different modes or different configurations. Coming to output side, we can observe three regions at output characteristics. One is cutoff region, second one is active region, and third one is saturation region. Okay. Coming to transistor characteristics, transistor worked as a switch in off switch in cutoff region, on switch in saturation region, amplifier in active region. Yes, I mean the types of field effect transistor. Okay, this is classified into two types. One is JFET, one is JFET. J means junction field effect transistor. The next one is MOSFET, metal oxide semiconductor field effect transistor, also called MESFET, metal oxide semiconductor field effect transistor, also called MISFET, metal insulated semiconductor field effect transistor, and IGFET, insulated gate field effect transistor. Again, JFET is classified into two categories. One is N-channel JFET and second one is P-channel JFET. Yes. Coming to MOSFET, MOSFET is operated in two modes. One is enhancement mode MOSFET and second one is depletion MOSFET. Okay, depletion mode. Again, this enhancement mode categorized into two types: N-channel enhancement MOSFET, P-channel enhancement MOSFET. Same depletion also, N-channel depletion, P-channel depletion. This question for exclusively a tree diagram of transistor types. You can draw like this. You will get good marks in an examination. Yes. Coming to third question. Discuss current components in transistor. What is the question? Discuss current components in transistor. First, immediately you can draw this diagram. Okay. The first, this is a P region. This simply you can observe this is a P region. The next one, this is N region. Okay. This is P region. Okay. These are all three regions. P is connected to positive, N is connected to negative here, N is connected to negative because of this is forward bias in input side, reverse bias in output side. Okay. Here P, obviously we can expect whole current because what question is discuss current components in the transistor. This is P type. Obviously it is a whole current. Then this is P. This is also whole current. At actually two bands. One is conduction band and valence band. In conduction band you may expect whole current. Forget about that one. Then majority charge carriers in P region, holes. Minority charge carriers in P region, electrons. That's why we can expect very small electron current. Minority charge carriers, electrons in P side. And the same time, reverse saturation current, that is called ICO. In coming to base, we can expect IPE minus IPC. Okay, IPE in P type, electron current. Okay, IPC, E means emitter. C means collector, that nothing but complete base current in N side. Okay, these are all currents in the transistor. At the same time, you can also write this equation also. IE is equal to sum of base current and collector current. Okay, summed up gives the emitter current is IE is equal to minus IC plus IB. You know very well, IE is emitter current, IC is collector current, IB is base current. If it is considered as a magnitude, negative is just removed. IE is equal to IC plus IB. Okay, in this current components, you may discuss some alpha also. Very simple. The ratio of, actually alpha is a current amplification factor or large signal current gain. Very simple. The ratio of the negative of the collector current to minus current increment, nothing but ICBO to IE, that is alpha. Alpha is equal to IC by IE. You can expect in common base configuration. Okay, that is called alpha. Okay, then the next question is write transistor current equation. A very simple, straightforward, you write this equation. In active region of the transistor, the emitter is forward bias and the collector is reverse biased. That's why we can write this one. IC is equal to alpha IE plus ICBO. It's a reverse saturation current. This is a diode equation also. I is equal to I naught into 1 minus something. This is also some looks like diode equation. But here you have to write IC is equal to alpha IE plus ICBO into 1 minus E to the power of VC by VT. Okay. Then we have to discuss some alpha beta values also. In this IC, VC is equal to collector voltage junction, IE emitter current, okay, and IE is equal to summed up collector current with the base current. You may ask, these are all equations, very important. Substitute this equation 1, IC is equal to alpha IE plus ICBO. Okay, this equation coming from this following equation. If VC or VT something is some treat as a 0, then the final equation IC is equal to alpha IE plus ICBO. The substitute simply IE value, you get this equation. Just see the derivation, you can understand how equation is get like this. Final IC is equal to alpha IB plus ICBO. Okay, this IBO, this is also one type of derivation. This is way to find alpha and beta values. These are all under coming into a current equations, like IC is equal to alpha IB plus ICBO 1 minus alpha. This can be treated as beta into IB. Here beta we can call it as a alpha by 1 minus alpha. This 1 minus alpha we can also call it as a 1 plus beta. Okay, 1 plus beta. So that is final current equation is equal to IC is equal to 1 plus beta ICBO plus beta IB. Okay, this is very important current equation for the transistor. You can also observe one more derivation, how to find alpha beta relations also. You know very well, alpha is equal to IC by IE for common base configuration, beta is equal to IC by IB for common emitter configuration. That is equation IE is equal to IC plus IB, universal equation. First let us take this equation, alpha is equal to IC by IE. What is IC? IC is equal to alpha into IE. Okay, now substitute IE replace with IC plus IB, this equation, right? This equation substitute IC alpha plus IC plus IB. Then next multiply with alpha value. Now IC is equal to alpha into IC plus alpha IB. Now just come all ICs in one side. Now take IC common. 1 minus alpha into IC is equal to alpha IB. Now write IC by IB is equal to alpha by 1 minus alpha. So already I have discussed IC by IB is equal to what? That is called beta. This is beta. Now beta is substitute here. Now the final beta value is equal to alpha by 1 minus alpha. Okay. Now again beta is in terms of alpha. Now we have to find alpha in terms of beta. How? Just you can check now. 1 by beta is equal to 1 minus alpha by alpha. Just split 1 by beta, 1 minus alpha minus 1, alpha will get cancelled. This minus 1 is come to LH side. Okay, 1 by beta plus alpha is equal to 1 by alpha. This 1 plus beta by beta is equal to 1 by alpha. Finally, alpha is equal to beta by 1 plus beta. As coming to a total discussion, the final expressions is alpha is equal to beta by 1 plus beta. Beta is equal to alpha by 1 minus alpha. These two are very important amplification factor in transistor characteristics. If we ask the some current equation, simply you can write IC is equal to 1 plus beta into ICBO plus beta IB, and one more equation already I have discussed, IC is equal to minus alpha IE plus ICBO into 1 minus e to the power of VC by VT. Right. Okay, thank you. Next video I will discuss some questions with answers. Thank you so much. Thank you. Bye.